So, being on the free response practice, we have the figure shows Mr. Hampton going vroom, shout out. He is driving on a circular track that is near a sidewall as pictured above. Mr. Hampton completes 1 lap every 8 seconds. So that tells me my period is 8 seconds. Because what that's saying is, I'm going all the way around the track back to where I started in 8 seconds. So that's why that's my period. At t equals 0, point B is located directly below the center of the track. Point B is 20 feet from the wall. So this is 20 here. I'll zoom in a little bit. It's 20 feet. The center of the track is 50 feet from the wall. So, nope, typo, or righto, I guess, 50 feet. As Mr. Hampton drives on the track, the distance between point B and the level surface periodically increases and decreases. And then it says we have a sinusoidal function that models the distance. You all know the drill by this point. We've done at least 20 of, or probably not that many, but we've done a lot of these similar problems. Remember, you need to label your y axes first, then label these. So to do that, remember this is going to be my farthest distance. And on my track, we can see my farthest distance is going to be all the way up here in purple, okay? Well, I got to figure out what my radius of the circle is to be able to figure out how far this is going to be. Well, if this is 20 here and this is 50, I know the difference between these two is going to give my circle a radius of 30. So this is 30 feet from the center. And I know that's not the best drawing ever, but let me see. Let me try to make it a little better. It's more of the center. So that's 30 feet. So I know my total distance from the wall here is going to be 80 to start, like the highest point. 80, and this is in feet. And then when I am at the halfway point, so I'm either right here in purple or right here in purple, I'm going to be 50 feet away. And here, this point B position, it just tells me straight up I'm 20 feet away. And it makes sense because I'm going up by 30 every time, so that checks out. And then for point F, remember, you got to think, do I start at 0 or do I not? Well, in this case, I am 20 feet at point B at the starting point. But point F starts at 80. So the first time I'm going to be 80 is after I rotate to this point. Okay, I went half my track. So I've went half a period. So half of my period would be 4 seconds. This is in seconds. And I know if I'm starting at 4 seconds to go all the way back and end up back there, I'm going to have to go another 8 seconds because that's how long it takes to go around the whole track. So I'm going to go 12 here, and then I'm just going to take the halfway points for the rest of these. Halfway between 4 and 12 is 8. Halfway between this is 6. This is 10. So my points here would be 480, 650, and make sure on the test you fill in these coordinates because that's what this says. 8, 20, then 10, 50, 12, 80. Okay. Then looking at the next one, the function can be written in the form a plus sign blah 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 blah. Find the values of constants a, b, c, and d. Notice it doesn't say you have to write an equation. Just give me the values, and I don't care about the order. So make sure to hit the dab on this. dab on this test because that's just the easiest way to do it. D is my midline. So if I look back at my graph, that's pretty easy to see. My midline is drawn for me already here at 50. So that is 50. And then my amplitude is the distance between my midline to the max or min. So here or here. And that is 30. Same thing as the radius of my circle. And then my B value is 2 pi over my period. And here my period was 8 seconds, so 2 pi over 8. So that gives me pi over 4. Now for C, remember I'm using the sine parent function. Draw that again. You're going to be seeing the sine parent function in your sleep. Starts here, pi over 2, pi, 3 pi over 2, and 2 pi. Remember, I start here, I go up, down, up, okay? And where does that first maximum point hit? So on the parent function, it happens at x equals pi over 2. And the reason why that's important is all of these deal with the horizontal places. This is just the horizontal, like the input. My t is basically, you can think of that as my x here. C is my phase shift, my horizontal translation right or left. And this is my horizontal dilation. That's what B does. It dilates it horizontally. So since all of this is working with horizontal, this is basically where I started at, okay? I started at pi over 2 because that's where I started at because my parent function is sine. That's how these are related. And now B times T plus C, let me write that as a T. This is kind of like the map from, I started at all this and I can undo this map over here to go to my destination, to my parent function. Like this is the map to my parent function, right? So I can have my starting point, have my map, and undo some of the values. Here's what I mean. So I've got pi over 2. My B value is pi over 4. And this T value is talking about when does my first max happen on my function. Like that's what I'm asking myself. When does the first max happen on my function? Well, if I go back over here, my T value here is 4. Like, because my first max happens right here. So, if I go back over, my T value is 4 plus C. And then I just slowly get C by itself. So divide by pi over 4. Pi over 4. Keep change, flip this right here. Pi over 2 times 4 over pi. That gives me 2. So 2 equals 4 plus C. Minus 4 minus 4. And that gives me negative 2 equals C. So let's write out and box it in to be nice to me when I grade this. Please, please, please do that. So let's go in order. A is 30. B is pi over 4. C is negative 2. And D is 50. And that would be very helpful if you did exactly what I did right there. Write them out in order, A, B, C, D, and then box them in. So now let me erase part of this. So the next questions are a little easier from here. So refer to the graph of H in part A. The T coordinate of T1 is at F, and this is at G. So on my graph, I'm looking from F to G. Let me highlight that. Okay, from F to G. Now, what's it asking? On the interval, which of the following is true about H? So this is, oh, sorry about that. We are talking just here at H. We're talking about the function itself. So, when I look here then, well, my values are between 50 and 80, which are all positive values. So my function is positive. I can cancel out these two. And my function is it's going down, right? It's decreasing. And then here, this is describe how the rate of change is, H is changing over the time interval. So we're still looking between F and G. And remember, we're looking at concavity. This part right here is concave down, like a frown. So you would say because the graph of H appears concave down over the interval, make sure to state this as a sentence, interval T1, T2, the rate of change is decreasing. Okay, and just a quick vocab review, that concave up means the rate of change goes up, it increases. Concave down means the rate of change decreases. That's what concavity is useful for. It tells me about the rate of change. So when you see rate of change, you know you're working with concavity. And same thing here. You see that this is talking about rate at some point. So part of it, at least, is talking about concavity. So name one interval on which the graph of H is increasing. So the graph of H is increasing. Just let's start with that part. The graph itself is increasing. So the function is going up, left, or right at a decreasing rate. Okay, that tells me I'm concave down. All right, because it's a decreasing rate. So if I have like a frown here, the increasing at a decreasing rate would be this first half, right? I'm going up, but I'm part of concave down. That's why it's decreasing rate. So one place where that happens is from K to P right here. Let me highlight that in pink. K to P. That is increasing at a decreasing rate, and that's from 10 to 12. So write that out. One interval on which the graph of, and you can't really write in italics here, so I like to put it in quotations, of H is, I don't even know if that's grammatically correct, that's just what I do, is increasing at a decreasing rate is, let me make sure I got the right points, it's from 10 to 12.